Solve the logarithmic equation. Be sure to reject any of the nasty. Give the answer. All right. We have logs, logs, and logs, so what we have to do is we have to combine these two logs on the left-hand side, because if I can get it to a log equal to another log, then the logarithms become irrelevant. There's a minus sign in between these, so I can combine the two logs on the left as a quotient. Now that I have a log is equal to a log, the logs are unimportant to the problem. I'm going to cross multiply the two to the right-hand side. I'm going to take the x to the right, the 6 to the left. I get x is equal to 3 divided by 5. Now, is that a problem? It would be a problem if I plugged it in here and I got a 0 or a negative, or if I plugged it in here and got a 0 or a negative. And I won't. That's a good answer. Number 5, write the equation in its equivalent exponential form. I could do that. Remember, the 4 here is the power that when you place it on the base gives you this large number. That's what they want. Solve the equation. Use a calculator. I don't have a calculator that can do that. Let's take it as far as we can go. We have 3 logs all together. What we want to do is we want to combine them. The plus sign here means I can combine these first two as a product, and anything with a subtraction sign automatically goes to the denominator to create a fraction. Here's what I'm going to do first. That 2. Anything on the outside, please move them back in as powers. Combine. Anything that is positive, no matter where it is, goes to the top of a fraction. Anything that is negative, no matter where it is, front, end of the problem, you put it on the bottom. Okay? Now that you have a log is equal to a number, remember that this number is a power, and that power turns this base here into all this other stuff. E to the 0 is a 1. Move this over here. I'm going to cross multiply the x squared over to the 1, and I'm going to go ahead and FOIL those two parentheses together. 2x squared, a 6x here, negative 6x, a 5x here, which will give me a negative x, and minus a 15. I'm going to bring the x squared over. And I'm going to, unfortunately, use the quadratic formula. X is equal to a negative b, which would be a positive 1, plus or minus the square root of my 1 squared, minus 4 times the a times the c. Well, that 2 over a. 1 plus or minus, let's see, this is 60. Let's see, the negatives will become positive, so there'll be 60 with a 1. That'll be square root of 61 over 2. Now, I know for a fact that if I went 1 plus the square root of 61 over 2, that's going to be a nice positive number. Square root of 61 is almost 8, so this will be 1 plus almost 8, which would be almost 9. Almost 9 divided by 2 is 4-ish. And if we were to plug a 4-ish here or anywhere, we would be fine. So that answer is okay. The other answer, the 1 minus the square root of 61 over 2, 1 minus almost the square, almost 8, will be a little bit close to negative 7. Negative 7 divided by 2 is negative 3.5. Negative 3 to negative 4, somewhere in that area. If we were to take a number somewhere between negative 3 and negative 4 and plug it in right here, no matter what, because it's negative and you take 3 away, that's going to be a problem. So, I cannot use a calculator. Well, actually, I can. I do have one that uses a square root. This is not going to be an answer. But the 1 plus the square root of 61, now here's how we're going to have to type that in. 61 square root plus 1, that's the top. Divide that by 2, round to 2 decimal places. Supercalculator. 4.41. Okay? Now I guess I didn't have to ramble about what I was saying a few minutes ago. But on the other one, 61 square root times, no, how am I going to do that? Because I can't times it by a negative 1. Clear. 61 square root I got to go 1 minus that. So 1 minus 7.81. 1 minus 7.81. I'm going to divide that by 2. And see, that can't work. Because if you were to plug in a negative anything, if we were to plug in a negative anything into that second expression, that would be a domain problem. So this answer does not check for this problem. Finally got you there.